Now, there's just one more thing I wanted to add, and that is this ejection fraction thing. Because on the surface, if you said something had a preserved ejection fraction, you say, okay, that sounds good, right? Okay, maybe not. So when we talk about systolic, let's say failure, right? So we have a problem with our pump. Can we get adequate blood out of the ventricle? Well, no, because the pump's not working right. So in systolic failure, you're going to get a decreased ejection fraction, right? Ejection fraction is the fraction of blood that gets out of ventricle compared to what was in there before. You're in diastolic volume. So this is the same thing as saying heart failure with reduced ejection fraction. Now, why is it reduced? Because the amount of blood in the pump is not working. The pump is not working. It's systolic failure. So when the pump squeezes, it doesn't squeeze as well. So that amount of blood you're gonna have a decreased ejection fraction, decreased amount of blood there. It is coming out that should have, okay? So the pump is not squeezing hard enough because it's floppy, there's dead tissue, then you're gonna get a decreased ejection fraction. So when we talk about the pharmacology behind it, there are certain drugs such as digoxin, which they don't really use anymore, but it's a very classic example. You can make the pump work a little bit better, okay? They love to test on it. So if it makes the pump, it's an inotrope. So if it makes the pump work stronger, you can help to rectify this ejection fraction problem. Now let's look at diastolic. All right, so now we have a filling problem. Now, if I told you you had a heart failure, but a preserved ejection fraction, you'd be like, well, okay, I mean, then I'm getting the right amount of blood out, right? No, that's not what's happening. The problem is that the heart is filling with less blood. Okay, so let's just I'll use arbitrary numbers here. Let's say you originally had 10 liters in your, I know you don't, but if you had 10 liters in your heart and you were able to eject 5 liters of that, all right? That's an ejection fraction of 55%, okay? Which is about, the liters aren't correct, but your ejection fraction is around 55%. That's what it should be, okay? Now, if we had a diastolic failure, let's say the heart was only able to fill with 8 liters, right? And of that 8 liters, you got 4 liters out. You were able to eject 4 liters, okay? Well, sorry, this would have been 50%, right? 50%, right, 10 of 5, you get it. So let's go back. If you had originally, before you had heart failure, you had 10 liters in your heart and you ejected 5, you'd have an ejection fraction of 50%, okay? Now you're in diastolic failure. Your heart can only fill with 8 liters instead of the original 10 liters. And you're able to eject 4 liters of that. Well, your ejection fraction is still 50%, right? So that doesn't mean that's not good. Like there's still less overall blood. You'd have to look at the actual cardiac output to figure it out. So just understand that preserved ejection fraction doesn't necessarily mean like you're getting out the amount of blood you should. It just means from the amount of blood that was in the ventricle coming out, you're still getting, the same percentages out of it. Okay, so just keep that in mind. If you have a pump failure here, you're going to have a reduced ejection fraction because the pump's not working. If you have a diastolic failure here, you'll get a preserved ejection fraction, but that's only because you had a problem filling. You weren't able to fill it up properly. Okay, so those are some of the tricky things. If you get those straight, some of those higher 3rd or 4th order questions, you'll be okay with.